Hi, I'm Paul Battaglia, and this is section 2.3, Polynomial and Synthetic Division. And what we need here is a good way to start this off because the concept of long division can be somewhat abstract. So I have Gabe and Brittany with me, and Brittany, you have a great introductory activity that you'd like to use with students, right?
Yeah, I like to begin with long division of just integers. That way students are more familiar with integers.
Right.
It may have been a while since they've seen long division, you know. But starting with that and really showing them step by step what is going on in long division.
And then Gabe, how do you find, because I know you do something similar, how do you find that translates that into the long division process?
Yeah, so like you said, I do something similar where I introduce long division of integers because it's something students have seen before. And I really make sure to point out all the steps that I go through when doing long division with integers, especially talking about how I treat the remainder.
Right.
And then I feel that ties in pretty naturally to how we do long division with polynomials. So I point out the similarities. There's some small differences, but it's more similar than not, and I feel like that really helps students get an understanding of how to perform long division with polynomials.
Right. And I think when I see them work with remainders, I think both of those, the integer lead into the polynomial division. I think it's important that they understand that if we were doing integer division and we had a remainder of 3 and the divisor were, let's say, 7, we express that as 3/7. So I want them to see the remainder of 3 when we do polynomial long division and still understand that that 3 has to be placed over the divisor, not just this dangling number.
Yeah, it's not just the plus 3 at the end.
Right, exactly, on the end, And so I think then what happens sometimes in textbooks is this process of synthetic division just kind of magically appears out of nowhere. So what we want the students to do is we want them to understand that synthetic division is an alternative method to long division. Now, that being said, it's not the only method, and it's not a method we're going to now use over long division as we go forward. So one of the things I like to stress to my students is, can we make sure that we know when to use it, right? So we're dividing by linear factors of the form, let's say, x minus k, because the last thing I want to do is just give them 5 synthetic division problems. I want them to see a problem later on where they're dividing by 2x minus 5. I want them to understand it's more appropriate here to use long division, right? Yeah. Now, with both methods, we're still going to see some errors, right? So, Brittany, I know you've seen a few, right, that you'd like to talk about.
For both the methods, long division and synthetic division, a lot of times students forget the placeholders. Right. And then also with long division, they won't put the parentheses around their terms. And so they'll subtract the first term, but then add the second term.
Right, okay. And I think one of the things that you can do, even when you go back to the zeros as placeholders, you can go back to that integer example, which I love. You could tell them, hey, 13 divided by 7, that would be different if it was 103 divided by 7. So that 0 makes a difference. We need it in certain cases. Let's make sure that we have it. So I hope these tips have been helpful for you and you find much success in section 2.3.